So, again, just some things with the basic rules. And I'm not going to go back through and write every single thing out like we did before. Might just do it on one of these just to remember one more time. Whenever I've got something to an exponent, it just means I'm multiplying it by itself that many times. And yes, I'm only going to do this once because we start cramping our hands doing this too much. So 7x's multiplied together, 4x's multiplied together, and oh yeah, if I don't see an exponent on something, I assume it's a 1. Now again, you can see visually why this would be a decent way of doing this, but do you really want to write that all out every time? Probably not. So I look and I'm like, how many do I got? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, and then it goes back and registers in my brain, oh yeah, there's a faster way to do this. 7 plus 4 is 11 instead of having to write all this out. So as long as I remember that, 1 plus 5, oh, that's much quicker. And I can get myself to a solution. Now the only thing that gets tricky with these is what do I do when coefficients pop into the front? Yeah, I'm still going to treat those like I would any number. I'm still going to multiply them. So I'd still do 2 times 5, which is 10. But then with my x's, I'm still going to follow their rule and add the exponents. So that's the part that can get to be a little bit tricky. And then I remind myself, oh yeah, anything to the 0 power is 1. Even if it's like 10 million to the 0 power, it's still 1. Kind of strange, but true. And we're going to take a look at why that is today, so it'll hopefully stick a little bit better. So just a review of the rule, when we multiply terms, we're going to add the exponents, but we're going to multiply the coefficients. So that hasn't changed, and that's also on your help sheet that you got yesterday. So that was one of the things we talked about the first day that we were dealing with exponents. The other part we talked about the first day was what happens when there's an exponent outside of my parentheses, when I'm going power to a power. Right, okay? Basically what I'm going to do, and we looked at it here, is it means I have 2 of these x to the 5ths. Well, I know that 5 plus 5 is 10. I could look at it that way. Or I could also look, oh, 5 times 2 is also 10. So if I got x to the 3 to the 4th, I didn't say that right, x to the 3rd to the 4th power, that's better. I could write it out as 4x to the 3rds. But again, that's sort of like when we were up above writing out all those x's. Who wants to write that out that many times to figure this out? Wouldn't make me imagine another rule, but it's not going to be as fast as if I just did 3 times 4. I get the same answer. 3, 6, 9, 12 if I add them up. But again, what if I put like a 10 or something out there? I don't want to. Knowing the rules is going to help me out more. But again, this last part's where it gets interesting. Because I have to remind myself, and I'm going to do this one last time. You're like, I thought you just said you don't want to have to do that. And I don't, but I didn't have a coefficient out front last time. Okay. I know that 4 times 3 is x to the 12th, okay? That part's not bad. And I also know that if I multiply those 2's together, 2 times 2 times 2 is 8. But the part that I may not have been thinking about before, and I apologize, I didn't have my graphing calculator up right away so I could show you this. There's a faster way even to do that if I'm not going to write all that stuff out. And again, I like finding ways to make things go faster. Instead, I could write this as 2 to the 3rd power, as though I was distributing that exponent through. And if I want to do that on the calculator, most calculators have an exponent button. On the ones we have in here, it's this up arrow. It's called a caret. spelled differently than the one you eat. And I can get it that way. So that's always an option that I have. Or I could just multiply it out like we did before, 2 times 2 times 2. So when we do power to a power, we multiply the exponents. So it's kind of weird when you start to think about it, and I can see how it can get a bit confusing. You're like, so when I multiply, I add, but when I go power to power, I multiply. Gee. Well, but that's why we get these notes, and we kind of give ourselves the opportunity to be able to use this on a quiz in case I get confused and things like that. Now then yesterday, we're going to get to see how much you listen to me when I'm physically not here. Dividing. Right. Now again, I'm going to do a couple here where I physically am going to look at it. X to the 5th means I got 5 of these guys. Sometimes it just makes it easier to see what you're doing before you just start trying to memorize a rule. So x to the 5th means I got 5 x's up top that I'm multiplying. X to the 3rd means I got 3 of them suckers on the bottom. And any place that I see the same thing in the numerator and denominator, I can cancel. So whack, whack, whack. And how this helps me is when I get to this point, I see there's 2 x's left, and I see they're both on top of my fraction. And I just write that, and I'm done. Now I kind of look at this for a minute, I'm like, hey, I wonder if it's a coincidence that 5 minus 3 is 2. Let's see. Let's keep playing with these. So let's see, 9. Oh my gosh, couldn't I have used a smaller number here? Maybe I got 7, 8, 9. At least I'm going to do something here in a minute to wake some of you up in the morning. So again, if I see something that's the same, I can see one on the bottom, one on the top. Each time I just whack them. And then whatever I've got left, 2, 3, 4, 5, 6, 7, they're all up in the top, and I've got my answer. And what a coincidence again. 9 minus 2 is 7. But there's one more part to this that we haven't talked about. We basically see now it's going to be subtracting. But there's one more twist that can get thrown in at us. So I want to look at this drawn out one more time. All right. And again, what was I thinking? 3 x's and 9 y's. 2, 3, 4, 5. I'm going to fit all these in. 6, 7, 8. And this is why we like the rules, because I wouldn't want to do this on every problem. I'd probably look for an excuse not to do it then. All right, 6 x's. Last one of these we're doing this on. And 3 y's. Okay. Give you a minute to be able to write yours down too. And I'm not going to promise I'm not going to go sound effect crazy again. So I stop and I think back for a minute to when I was doing the multiplying on the other side. And you're like, now you said on the other side, when I'm multiplying, I actually multiply the numbers. Here, I'm actually going to divide the coefficients. Okay, I'm not going to subtract them. So 10 divided by 5 is 2. And wherever the larger number is, that's where you put your solution. So like if the 5 would have been on top and the 10 would have been on the bottom, I'd have put the 2 on the bottom, wherever the bigger number is. So then I do like what I did before. I'm going to start canceling the variables until I run out of them in one place. So like I start going with the x's, I go, okay, until I run out of x's up top. So then I notice 1, 2, I got 3 left down here. So that's where my x to the 3rd has to go, and it matters. I can't just put it wherever I want to. Then the y's, I'm going to do the same thing. I'm going to start whacking away here until I run out, and then count 1, 2, 3, 4, 5, 6, and they're up top. So that's where the y to the 6th has to go. So there's a little bit of a twist as to how my rule goes. We're not just going to strictly use it as subtract the exponents. So here's how this is going to work. When we're dividing, we are going to subtract, thank you, the exponents, but it's going to be the larger minus the smaller one. And the second little part of that is the answer goes with the larger exponent. And when you've had a chance to jot this down, I'll actually explain what I mean using this last example that we did and how you can kind of help yourself to where you don't end up putting your variable in the wrong spot. Because I don't want you to go to all the work of doing this and then have something go bad on you. So I kind of start to look at that last one and I go, okay, so 10 divided by 5 is 2. I put the 10 was bigger, I put the 2 up top. Okay, but what about the variables? What about the exponents? So I look at the x's for a minute and I go, okay, bigger minus smaller. 6 minus 3 is 3. The bigger exponent's down below, so that's where my x to the third ended up. Then I look at the y's. Bigger minus smaller. 9 minus 3 is 6. The bigger exponent's up top in the numerator, so that's where my y goes. And that's how I do this with my rules. I know some teachers always teach it as it's the top minus the bottom. It's the numerator minus the denominator. But then you have negative exponents, and you got to worry about flipping them. Who wants to get into all of that? So that's just an easy way to avoid that problem. So once we went back over that, because that's basically all the rules, I wanted you to actually see, sort of like what we did up here, because it actually can click a little bit better sometimes when we see things. I want you to see why anything to the 0 power is 1. Because a lot of times people will tell you that, but they don't really tell you why. So what we're going to do, I'm going to pull the calculator back up here for a minute. And we're just going to do some calculating. Okay, I already got 2 to the third up there. Okay, so 2 to the third power is 8. What's 2 squared equal? 4, because it's 2 times 2. 2 to the first power is just 2. We keep saying over and over that anything to the 0 power is 1. Now this is the part that gets interesting if you haven't had a lot of experience with negative exponents. Negative exponents don't mean negative answers. Yeah, if I type that into the calculator and I don't want the decimal, so I'm going to hit math, enter. I notice that it's 1/2. And you're like, okay, so what? Ooh, I wish I could make this calculator just a little smaller. Well, let's do it again with 2 to the negative second. And again, I don't want the decimal because that's not going to show what I need here. Okay, so that's 1/4. And 2 to the negative third. Again, I want the fraction is 1/8. Now, let me shrink this down for a minute. Let's look at this. I see a pattern developing here. And the pattern I see is 2 to the first and 2 to the negative first are inverses. They're opposites because if you think about whole numbers as fractions, 2 to the first and 2 to the negative first, I just flip it. 2 to the second and 2 to the negative second, I'm just flipping the fraction. 2 to the third and 2 to the negative third, I'm just flipping the fraction over. So all that this negative exponent does is it takes whatever this would normally be, like 2 squared is 4, and it flips it. And that's also where this comes from. Because if you think about the rule for a minute, if I did 2 to the first power times 2 to the negative first power, you're like, well, 1 plus negative 1, it'd be 0. Right. But if you take 2 times 1/2, that's just 2 over 2 or 1. That's where this comes from. That's why anything to the 0 power equals 1. because that works with anything, whether it's a number, a variable, or anything like that. So sometimes it's just interesting to see where these things come from. And then we just reinforce it. Anything to the 0. Anything. Even variables. 1. It doesn't mean it's that to the first power. It means this part's gone, and it literally is just 1. And then negative exponents was the one other thing we got into yesterday, but we don't like negative exponents. We need to change their attitude and make them more positive. Life's much easier when things go positively. So whenever we see that negative exponent, we're going to flip it. We're going to try and give it an attitude adjustment. So if I see something with a negative exponent, okay, and it's not in a fraction, I'm going to kind of pretend it like it is. I'm going to put it over 1. But here's the part that gets interesting. I only get to flip the parts that are negative. Like here, my negative 1's only on the x. It's not on the 4. The 4 has a positive exponent, 1. So the 4 doesn't flip, but the x does. And in this case, I can't cancel anything, so I'm just done. And that's how I'm going to work. Thank you. So with any of these, my response to you is always going to be to deal with the negative exponent right away. So like for instance here, and this might seem strange to some of you, but it works. The negative 10, just because a number is negative doesn't mean it flips. Only if it's a negative exponent. X to the negative third is going to flip, and when it flips, it becomes positive. It changes its attitude. So when I flip this up to the top, it becomes positive. You're like, why would I do that? Because I don't like dealing with negatives. So I look and I go, okay, now I'm multiplying them. So I add them up. That's where all these rules come in handy. And if I'm not sure what 5 over negative 10 reduces to, now if you do, sweet, go with it. If you're not sure, let the calculator help you out. 5 divided by negative 10. Math, enter, enter. Negative 1 over 2. And I'm set. Okay. So those negative exponents got to get flipped. Even if there's a negative outside here, okay, no big deal. I'm going to distribute it. So I got 6 to the negative 2, and I got to multiply those guys because it's power to power. So 3 times negative 2 is negative 6. But negative exponents, attitude adjustments, flip them. If it's got a negative exponent, heads to the other place and becomes positive, whether that's heading up or heading down. Negative exponent, heading down. There's nothing left up here, Harty. Well, there needs to be. If you ever get rid of everything somewhere, replace it with a 1. Even if it's a fraction. And then, of course, I want to simplify what I have. 6 squared, again, is not 6 times 2. It's 6 times 6. And I'm ready to roll. So this might be the best sheet of all the notes we've done so far because it has everything on it. There's no rule that we have discussed that is not on here and doesn't have an example for it. Now, putting this to practice can be a little more challenging sometimes because, let me move this out of the way for a second here. Our homework sheet for today is in our 4th homework check, the last one, like I mentioned at the start of class. This is number 4. And since we always wait 2 days after we do the last one, we don't have school Monday, so Tuesday, Wednesday will be the next homework check. So I look at these and I'm like, okay, doesn't look awful. We're going to take a look, and I think there's 2 problems on here I want to do. I want to do number 1, and there's one I want to do on the back here. So here's my suggestion. I would actually, if I see any negative exponents, rewrite the problem and have them be positive. So I'm like, okay, the 3 is good where it is. So is u to the 2nd. V to the 4th, negative 4th, that's a problem. So I'm going to move that down below so it becomes positive. Because again, don't like dealing with the negative exponents. Everything down below is good though. So I'm just going to recopy it quick. Because now what I can do is I can look for the things that are alike and simplify. So like 3 over 2, okay, that doesn't simplify. I can't divide that. So I'll just leave them alone. But then I start looking at my variables. And I'm like, hey, all of my v's are together here now. I'm multiplying them. So since they're in the same place and I'm multiplying, I'm just going to add them up. V to the 4 plus 3. It's going to stay where it's at. It's v to the 7th. But my u's, I have to be careful. I'm dividing. And we just got done saying when I'm dividing, I'm going to subtract them. Bigger minus smaller. 3 minus 2 is 1. Wherever the bigger exponent is, that's where my answer part's going to be. And then I'm going to be done. That's what we like about not having the negative exponents there for long. Just flipping them right away. It makes things easier. So when I get to trying to simplify, I'm not trying to flip things all over the place. Okay? The other thing that might be a little challenging, but again, that's why we take time, kind of work on these, can ask some questions that way, is over on the back. There's a couple of doozies back here, especially like number 25, which I want to do with you. It's kind of our big old review of this. You're like, how do I do this? Look at all these exponents and parentheses all over the place. We're going to take things in pieces, and then we're going to simplify. So here's where we're going to start. We're going to start inside by simplifying those two guys, because it's the first sets of parentheses we got. We're always going to work inside out. And I know some of you like to do all this in one step, but that's kind of tricky sometimes. So I'm going to distribute this through. Now 2 to the 4th power, I better double check here. Because again, 2 to the 4th power. There's my power button, my caret button. Okay, 16. So 16, 4 times 4, power to power, x to the 16th. Okay, got my 3 out here still. And then in here, 2 to the 3rd power, if I'm not sure. Okay, 8. Multiply my exponents, y to the 6th. So it's a little better. At least I got a couple of sets of parentheses that aren't there anymore. But I said I'm going to work my way out. So my next job, now that I've got those gone, is to work on simplifying all this stuff in the parentheses, because I don't want to have to take that 3 to all this stuff. That's going to take a long time. So I look again and I go, okay, let's see here. What's 16 divided by 8? 2. And since the 16's bigger, the 2 is going to go on top. Then I start looking around. I'm like, okay, what other variables have I got that are the same? Ooh, I see my x's. They're both on top. So what am I going to do to their exponents? Since we're multiplying the x's, what do we do to the exponents? Add them. Okay. Multiply is add. So 4 plus 16 is 20. And then my y's, it looks like we're dividing, because some are in the numerator and some are in the denominator. So what do we do when we're dividing with exponents? Subtract. 6 minus 2 is 4. Bigger exponents in the denominator. So that's where my 4 is going to go with my y. Okay? Bigger exponent is always where your answer is going to go. So I got that all cleaned up nice. All this junk's turned into that. And now I'm ready for my last step. So this 3, my exponent, is going to go to the 2, and in my x to the 20th, and down here. And power to power, we multiply. So I have 2 to the 3rd power, which we just did up here. That was 8. 20 times 3. Yes, you can get some big old exponents with these. So x to the 60th, and 4 times 3 is 12. And since these are different bases, they're different variables. But again, this is an extreme problem. Most of the problems like the ones you're going to see are in those first 20. I just wanted to put a few challenging ones in the end just to kind of make you do multiple rules at a time. So take the rest of this time. Do not just close up shop for the next 16, 17, 18 minutes here. Do some of these. Try this out. I'm going to put the key up here on top of the projector and do a few and then check them. See how it's going. And you look at them and see what's going on. And then try to, if something's not working, try to figure out what's not working and fix it. Because if I'm always the one fixing it, then you get to a quiz and you're not knowing how to self-fix. So try those out. Do a little work with those. Or maybe you got to finish a couple over the last couple of days. But do those and then we'll have you ready early next week for a quiz.